All right, here we go. I always enjoy starting a video lecture with "Here we go" because I just do. I don't know. I don't know why. All right. Shh. Thanks. So, linear transformations. So I want you to put into your calculator the set of data. Lecture. Yes. Let me change my pen color here. Let's go 2, 5, 7, 7, 9, 10, 15. Okay. I need a mean, a standard deviation, which I'm going to abbreviate SD in your calculator. It's the one that's the S with a little x. I want a median and an IQR. Okay. We there? Ladies, are you keeping up with us? Okay, cool. Then give me my list. Who's going to volunteer my list? Because I didn't put it in my calculator. 7.857. I'll call it 7.86.
Standard deviation is
4.09. Median?
Median is 7.
IQR? 5. Okay. Q3 minus Q1. Okay. Guys? Thanks. Now I'm going to say that I didn't mean to put this piece of data in as 2, 5, 7, 7, 9, 10, 15. I made a mistake. It should have been 20, 50, 70, 70, 90, 100, and 150. So throw that into your list to give me a new set of statistics. I'm going to call this data set capital X. I'm going to call this data set 10 times capital X. Okay? So when I look at my mean, I'm going to find the mean of my new data set, so I'm going to call it 10 times capital X, sub 10 times capital X. When I look at a new standard deviation, I'll say it's the standard deviation of this new data set, 10 times capital X. The median of 10 times capital X, the IQR of 10 times capital X, and I need those numbers. What's the mean? 0.555. Okay, so we'll call it 78.6. I'm just going to go that many. So median? IQR? Okay. When I took every number in my set of data and I multiplied it by 10, What happened to my statistics? They're all multiplied by 10. All right, that's pretty simple. Okay. Now I'm going to take each one of those numbers, and I made another mistake. They all should have been 5 more. So this is the data set 25, 55, 75, 75, 95, 105, 155, and I'm going to call this, it was set 10 times capital X, and then I added 5. You'll see in just a minute. So I need a new mean, a new standard deviation, a new median, a new IQR for this new data set 10x plus 5. All right. What's my new mean? 83.57, I'll call it 6. How does it relate to the previous mean?
Bigger.
By how much? 5. What's my new standard deviation? Oh. How does it relate to the previous standard deviation? Unchanged. New median.
75.
How does it relate to the previous one? Plus 5. What's my new IQR going to be?
50.
How does it relate? The same. Okay. What's the point of all this? Okay. If you do a linear transformation that is about multiplying, about scaling up, so these are called linear transformations because they're like a, mx plus b kind of thing. That's just a scalar multiplication then all of the statistics get the same, we'll just say get scaled up. How about that? Okay. If you do an addition or a subtraction for your linear transformation, I'll get scaled up. Sorry. If you just do an addition or subtraction to your data, then only the measures of center get the addition. Yes. If you do an addition or a subtraction, this one was an addition that we just did, only the measures of center get the addition or the subtraction. Okay? The measures of spread stay the same. Why does it work out that way? Well, my data, if I just add a little bit to it, stop that. If I just add a little bit to my data, I don't spread it out. I just move it over. If I just subtract something from each number in my data, I just move it over. It's not more spread out. or less spread out. So transformations that are just additions or subtractions of every value in the data set, every value in the data set gets transformed by an additional 0.7. Well, the mean's going to go up. My center is going up. But my data is not more spread out than it used to be. If I'm multiplying by 10, then yes, my center's got to change. And does the data become more spread out? Well, it was going from 7 to 15. Now it's going from 70 to 150. That is a lot more spread out. Okay? I have got to get that thing turned off. All right. So let's just look at a problem here. So let's say that you had some data set that had a mean of 20, a standard deviation of 3, a median of 19, and an IQR of 5. And let's say that you added 7.9 to every value in that data set. Okay? What's your new mean? What's your new standard deviation? New median. Can't do that one in your head? Good. New IQR? Okay. Instead, let's multiply, and I'm going to keep it easy. Let's multiply each value by 10 and add 2. What's my new median? Okay, so I'm actually going back to the 20. So I multiply that by 10 and get 200. Add 2 and get 202. What's my new median?
30. 192.
Okay. Now my standard deviation and my IQR.
Why do those always stay the same?
They only stay the same if we have done addition, but the multiplication makes us more spread out. So what's my standard deviation? 30. Don't add the 2.
Why not? Oh, addition.
Yeah.
Got it.
Okay. What's my new IQR? 50. Don't add the 2. Okay. Cool. I knew I could do that in 10 minutes. You have a few homework problems? No. Yes, you do. Yes, you do. Come on. Of course you do. Well, let's do the homework problems like we did the other day for a homework quiz. I like that. Turn off. Function 11. Isn't that a print screen? Okay.